I'm gonna check. I'm gonna record it from this point on, and
No, it's coming right now.
I'm muting everyone from this point on. I guess there are some of you unmuted. Okay, so this is going to be recorded and it'll be uploaded on YouTube, and I'll share the link on our Google Classroom. Okay, for those who just joined us, attendance will be done on a daily basis based on the task that's posted or Zoom session that we'll have. For your period, based on kind of the block schedule, um, let's see, for this week, I'm really only going to see you guys twice today, like right now. And then on Friday, there is an optional kind of a Zoom session where I'll go more through some of the math practice problem for this topic of gases. But every day there's like a task that I need you to do to either like submit a Google form or submit a classwork that that needs to be scanned or something along that line, and that's how I'm taking attendance. For those who've been out or you're missing some things from previous weeks, so let's say you did some labs that has to be graded still, then what I'd like you to do is scan any of that work, email it to me directly, and I'll grade that, and I can upload or update your grades. Since again, now it's harder for us to turn in physical things, it's just everything has to be done through scanning and then sending it over. So please make sure, double check your grades. I'll try to keep it updated. Finishing up with the extra credit that you guys submitted, and then I'll update that as well. All right. Let's see. Okay, so what is due the next couple days? You and your partner was last Thursday and Friday. You were working with your partners. Thursday was the POJO for phase change. It was that like 3 or 4 sheets of paper that you worked on. And I think for the most part, everyone was done, and we just didn't have the chance to turn it in. If you turned it in physically Friday, let's say when the sub was there, you handed it over, then you don't have to. Obviously, you have nothing to upload tonight because I picked up all of those documents that were turned in last Friday. If you have not done so, like meaning you or your partner has that paper, then scan it and make sure to upload that under our assignment page on our Google Classroom. You'll notice there are three things posted just this morning. There's the PowerPoint I'm going to be using today. That's one. There's an assignment page for the pair work, and then an assignment page for the individual work. So the pair work was Thursday's POJO and the concept map for solid and liquid. So between you and your partner, I only need one person to turn it in. Just make sure both your names are on it. So you don't have to, just verify with your partner that they've turned it in. That's the pair work. And then the individual work was, remember we had the activity 14 from your textbook. We spent a couple of days where I asked you to answer some of those questions. Can you scan those pages and upload it on that particular assignment? Like there's a separate assignment in Google Classroom for it. The other thing we did that was individual was we read an article about the glaciers melting, and then I asked you to answer some questions about it. So if you could scan that as well and upload it together. So to repeat what's due in the next couple of days, meaning tonight or tomorrow night, depending on kind of how far behind you are in terms of catching things up, is the pair work, so Thursday and Friday's work, and then the individual work, meaning your activity 14 and the answers to the melting glaciers questions. All right, so those are the two things. If you check the schedule tomorrow, there's no Zoom session with your period because tomorrow will be for the odd number classes. So for today, it's just the even number classes, and then tomorrow will be for the odd number classes. In terms of the attendance, as long as you turn in the pair work and the individual work, then I'll mark you present for both days, for today and tomorrow. All right, I'm gonna share a PowerPoint with you guys. So let me go under share. Okay, and this this is posted, but there are some things that it's better if you hear it, hear some explanation. So I'll go through this PowerPoint, and there's a portion where actually I'm going to be doing a demo. All right. This unit, solid, liquid, and gas. Solid and liquids, there's quite a few vocabulary terms. There wasn't really much math calculation that we did for it, but for gases there are there are concepts and there's some math that we're going to be working on. The next couple of days, that's our focus, is to look into what are the key ideas about properties of gases, and most importantly, how do we do certain calculations related to it. Give me 1 second. Let me make sure I can see. Cameron, you don't have to take notes on this because the PowerPoint will be posted. It's one of those where it's best that you just kind of listen to the conversation. Obviously, if you feel like you want to, I can't stop you from doing that, but you're not obligated to. All right, so let me go to, all right. I'm gonna see if I could, I'm hoping you guys can see it. Actually, let me check in with one of you. I guess the one's most visible right now. Cameron, I'm gonna unmute you. Can you verify that you can see
it's perfect?
All right, good. All right, let me just mute you again. So the earth science topic that's related to this particular one will definitely have to do with our atmosphere. So keep in mind that atmosphere is comprised of many different gases, and not just that, but there are many particles that are not necessarily a gas, like dust and pollen are in our atmosphere, but it's not necessarily a gas. The most prevalent gases in our atmosphere would be nitrogen and oxygen. And oddly enough, argon is the next one in line in terms of its prevalence. And something that, since it's difficult for us to do this discussion, but the idea here is that we know that the further you go up in the atmosphere, the less amount of gases that are present there. Therefore, there's less air pressure the further you go up. All right, so looking at these questions, if I could, blocking some part of it. The idea is that in order for us to do any of the math calculation in this topic, we need to assume that the conditions follow what's known as the kinetic molecular theory. And these are the 5 conditions set for to kind of help us understand and do all the math calculations with regards to gases. Looking at the options here, so let me give you some time I'll read it out loud, and there's some options. In the next slide, we'll have the answers. But kinetic molecular theory, if all assumptions are met, it's an ideal gas. It's one of the assumptions. If, number 1, a lot of the particles are, 2 options, are they close together or are they spread apart? Number 2, the gas particle, when they're colliding, energy is not lost. It's just, we have a missing vocabulary term. Number 3, that the particles are in continuous random motion. So there's no option there. And number 4 says no forces of attraction or, and then missing information. And 5 says kinetic energy is either directly or inversely related to temperature. So these are the 5 assumptions. And since we can't really fully do a discussion, here are the answers. So based on the kinetic molecular theory, we're assuming that the particles are spread apart. We're also assuming that when they collide, that they're not really losing their energy, that they are in fact maintaining that energy. Oh, can we not write on things? I thought I had modified that. So the other thing would be that there's a continuous random motion, that there are no forces of attraction or repulsion, so that the molecules are always that they're always moving, like they're not like stuck together. That's essentially what they're assuming here. And then finally, that the greater energy that they have, the greater the temperature, which we know when we talk about temperature, we are in fact referring to the average kinetic energy. All right. So these are some of the key properties of gases, and it's one of those matching type of vocabulary. So give yourself a little bit of time to look at the 6 vocab and the 6 option. And I'll discuss the answers. Keep in mind this PowerPoint will be posted. All right, so here are the main properties of gases that we're focusing on. We're assuming that gases they have the ability to expand and take up the space, the container that they're in, that they're able to fluidly move past each other, or they're kind of like gliding past each other. Their density is dependent on how many molecules of gas in a certain area, and that we can compress them, and when you compress them, you're increasing the pressure. Finally, the last two, they sound the same, but they're different in terms of what they're looking for. Diffusion is the movement of gases from high concentration to low concentration. And then effusion would be, if you have a container, let's say you have a spray, like an air freshener, then the idea here is that you have these aerosolized gases that's being released through a tiny opening, and the rate, or how fast that's happening, is known as the effusion rate. So the particle escaping through a tiny opening is known as the effusion rate. So these are some of the main 6 properties of gases that we are, in terms of the vocabulary terms. All right. Now, the next few days, I'm going to be asking you to do some practice problems on solving these gas laws. So that's kind of like the big takeaway for this week is, how do we predict what will happen if we know some of the conditions and then there are changes in that condition? Like if I know the pressure and the volume, what will happen to temperature? Something along that line. The first one is called Boyle's law. And the idea for Boyle's law is that if I have, if I change the pressure, what will happen to volume? That's like, to paraphrase what this law is saying. But in order for me to talk about that, I have to assume that the temperature of the container and how many gas are in there, number of moles, remains constant. It turns out that they are inverse of each other. So imagine if you have a balloon and the initial volume is about maybe this much. But if I compress that balloon, isn't the pressure increasing? So doesn't it mean that when the volume's going down, the pressure is going up? So they are inverse of each other. So think of balloons and compressing it. Charles' law, on the other hand, has something to do with volume and temperature. And if what we're changing is volume and temperature, then we're assuming that pressure and the number of moles must remain constant. Now, a way to imagine this would be hot air balloon. So if I have a hot air balloon and I'm increasing the temperature of the gas inside that balloon, don't they keep expanding? Which means if I increase the temperature, the volume goes up. So one goes up, the other one goes up as well. Isn't that a direct relationship? So Charles' law is saying that assuming that pressure and the number of moles is constant, the size or the volume occupied and the temperature are directly related to each other. Third one is known as Avogadro's. And the idea is the same, where if you have volume, but this time around, instead of temperature, we're looking at the number of moles. We'll still use the balloon analogy for it. If I have a balloon and I'm adding more gas to it, doesn't it keep expanding? So we're assuming that the temperature and pressure remains constant. So anything that's not part of the formula, we assume it's constant. And isn't it a direct relationship? Because the more gas we add to that balloon, the bigger it gets. So they are directly related to each other. I'm going to do one demo related to one of these properties. So we're going to move over to my follow me as to the kitchen. All right. Okay, Nisi, I'm going to unmute you. I just want to make sure that you guys can, I need to test the audio since I moved to a different spot. Oh, actually, it's all right. Okay, Nisi, can you hear me?
Yeah, I can hear you.
Okay, just turn up. Okay, so I'm gonna set up a demo. Let me unmute you. And what I have here is just an empty soda can. And I'm just gonna add some water. So I didn't add too much. I just want to make sure that this experiment happens quickly enough. And light up the fire here. Okay, so we move the, so all I've done is basically soda can with water and gas stove is on. What I also have is a bowl of water with ice. And so something to keep in mind the next few days while I'm waiting for this to heat up. A lot of the math calculations that you'll be given will require or will always provide enough numbers and information, but there's always one variable that's missing. All right, Cameron raising his hand. Let's see how I can switch back. Give me a second. Let me try to figure out how I can switch back so that I can see her. So, oh, I see. Okay. I'm going to stop sharing then and there'll be the larger screen. I think that's what you're looking for. Is that better now? Okay, good. So what I was talking about was after, so I'm going to do this demo, and once we finish this demo, that will be kind of like the end of the session. The PowerPoint that I posted, what I'd like you guys to do is to look over the subsequent slides, because what it'll do is introduce a topic, give you a formula, and then a practice problem will be on the next slide, and I'd like you to try that out. In addition, on Google Classroom, I posted for every single formula, I posted links to videos that explain each one of them, but in addition, like other practice problems that explains each of those calculations. On Friday, that would be the day where it is an optional Zoom session, but you guys will get the chance to ask questions, most likely on the math. That's usually what people need most help with. And then I'll try to do some practice problems where I can show you the solution along the way there. All right, I'm just checking on this thing. I need to make sure that it's hot enough that we can see steam. All right, so I'm starting to see steam and I can kind of hear it boiling. Ooh, let's not drop it. I'm trying hard to balance this. Okay, I'm gonna move this further back because I need you guys to see. All right, I know you can't see me, but you can see that the can is there, and then there's this bowl with ice. Move the camera further down. Okay, so the idea again is that I'm heating up the molecules, the gas molecules, turning it from liquid to gas. And keep in mind that isn't the pressure inside increasing by giving it more kinetic energy. So we're breaking apart the intermolecular forces. The molecules are moving more because they're now in the gas form, creating increased pressure inside. But what I'm going to do is I'm going to turn that soda can and place it in this bucket of ice or bowl of ice. All right, here you go. 3, 2, 1. Okay. So notice that we have, this is our before, this is our after, and it's completely crushed. And part of what I need you guys to, set that down. Not this part. All right. Part of what I need you guys to look into as you're going through these PowerPoint slide that I'm posting is to kind of look into what happened there? Like, how can we explain that? The task for, let me see our time. Okay, we have a couple minutes left. So the task for today is to, 1, upload all of those pair work. Number 2, upload the individual work. So there are 2 separate assignments. And then for today and tomorrow, start looking through the PowerPoint, the remainder of the PowerPoint slides I've posted, to looking through each of the formula and explanation and the practice problems that goes with them. Because I won't really see you guys until Friday again when we have our Zoom session. So let me open up, I'm gonna unmute, so like people who have questions can ask. All right, does anyone have a particular question or something you need me to clarify? I like all the pictures you guys have as your background there. Apparently I could change my background so I could be like in a different location or something like that.
Yeah, if you like go to, I think it's right to the right of stop video. I think choose virtual background.
I have to explore.
Oh God.
That. Oh good. Yeah. Oh, I see. Yeah, you guys have. So. Oh. You're in San Francisco. But for right now, like we'll find a way where we actually still have a discussion. The only concern that I have, that's why I muted everyone in the beginning, is that sometimes the background noise adds up with there's like 34 people with like even small background noises kind of accumulates, or the echo. So like if I'm talking and then you're hearing me on your end and it feedbacks and it kind of ruins the audio. But the goal for this next week, it's a mixture of independent work, meaning like go through all the resources I'm posting and making sure that the task that I've assigned you guys that you work on that. In terms of one thing that I haven't, good thing I have this checklist. We're supposed to have a quarter exam, but because of this week's schedule, that's not obviously going to happen. So for those of you, later this week, I think by Friday, I'll have a Google form. Those of you who had missed the quiz or a test, automatically we know which one to drop. We're dropping that quiz or test. For those of you who took all the quizzes and tests for the chemical reaction unit, then you have a choice which one you would like me to drop, or if you want me to drop anything at all. So the idea again is that since we can't do the quarter exam, instead of, and the quarter exam was designed to replace missing or low score, then we're gonna do that, but by just now dropping the lowest score or dropping the missed. So Friday, keep an eye for that Google form, because that's kind of how I'm gonna keep track of like who, because at the end of the day, you decide if you want to drop any of the quiz score. What if you did well enough and you're like, I don't want anything to change, then we just keep it as it. The only thing that we can drop are the chemical reaction quiz and unit test. So not the stoichiometry, because remember the stoichiometry we were able to do a retake for all of those quizzes. Any other question? Because it's now 11:30. I timed us to have a 30-minute session today.
For the pair work we're turning in, does only one of our partners need to turn in?
Yes, yeah. We just need to make sure that both your names are on it. So as long as you and your partner turn that in, then that counts. And then, Aiden, you had a question?
Yeah, so me and my partner turned in the circle, like the one where it had terms. We had to like match that. We haven't turned in the other one. Is that okay? We just turn in the other one that we haven't turned in yet?
Yeah, so
Right.
you mean you turned it in person, like on paper?
Yeah. Like,
Whatever was turned in last Friday, when the sub was there, I came by this weekend and I picked it up.
great.
So
Okay.
if it was turned in, I'll give you. Bless you. Oh, is someone sick? All right. Well, stay healthy, everyone. It looks like one of you is already sick, sneezing. But we'll catch up again on Friday. Check every single day on Google Classroom and email. I'll keep checking my email and try to respond as quickly as possible. All right. Bye, everyone. Have a good day.
Yeah. Bye.
Right. Now, Girl Scout.